Hi everyone, I always like to start this talk with a little moment of Zen. Whenever I look at this video, it just puts me in a place of calm and peacefulness. And these days, we can really use those little moments in our days, I think. So anyways, today I'm going to be providing a brief overview of when, where, and why we may want to consider herbivores when developing strategies to enhance the persistence of coral reefs. And before I get started, I'd just like to emphasize that all of the work I'll be highlighting today was very much supported by CIMAR. And without the CIMAR divers and researchers, none of this work would have been possible. So just a huge shout out of appreciation for CIMAR. All right, last looks, I'm about to kill the mood. So in the world of coral reef conservation, this photo speaks volumes about the formidable challenge we're up against. With the elephant in the room, of course, being climate change, and the global scale of this issue makes it both complex to mitigate and difficult to address its far-reaching effects on coral reefs. But in the meantime, we are striving to give our reefs the best chance of persistence by implementing local solutions that help support ecosystem resilience. And to that end, herbivore management has been gaining traction as a promising tool. All right, so why herbivores? On coral reefs, algae and corals are in this constant competition, and herbivores can regulate that competition by removing algae and thereby help maintain reefs in a coral-dominated state. Following mass coral bleaching events, herbivores have been linked to reefs that were able to recover to their pre-bleaching conditions. Where reefs that were able to maintain more herbivores, both in terms of greater biomass and higher functional diversity, those reefs had a greater likelihood of recovering. Enhanced herbivory is also a core component of natural positive feedback loops that further prevent reefs from shifting into an algae-dominated state. And jump-starting these feedback loops can help regulate entire ecosystems with relatively less human intervention, which makes this approach of enhancing natural reef processes relatively cost-effective. And we have a great example of this here in Hawaii with the Kahekili Herbivore Fisheries Management Area, which is a no-take area specifically for herbivores off the west coast of Maui. Kahekili was first created in response to these recurring algal blooms that took place back in the early 2000s, and managers started to notice corals were declining at a concerning rate. In order to address this issue at scale, the idea was that perhaps the herbivores could remove all of that algae instead of divers. But in order to test this idea, the herbivores first needed to recover in this heavily fished area. Since Kahekili went into effect in 2009, herbivores substantially increased in biomass, and large schools of these fish started to appear on the reef. When we look at how the sizes of these fish have changed, we see clear increases across the larger sizes, which are also the sizes most commonly targeted by fishing. These increases in herbivores nicely aligned with low levels of algae maintained through time, and despite multiple bleaching events, the reefs increased in crustose coralline algae, which is an important reef calcifier, and the loss in coral cover was fairly minimal. Since 2018, Hawaii has experienced another moderate bleaching event, and we all went through that whole COVID pandemic thing that was awful. And unfortunately, when we were able to survey Kahekili in 2021, it was clear a lot of those promising gains in herbivores had been lost. And the status of reef calcifiers was trending in an unfavorable way. When we look at how the sizes of parrotfish have recently shifted, The evident declines across the larger sizes suggest that herbivores were likely being fished. Now, although these recent findings are very disappointing, they do highlight some key lessons learned about this management strategy. The first being that enforcement and compliance is critical, as is true of all management areas. But in the case of Kahekili, all of the hotels that line the entire stretch of coastline, they serve as de facto enforcement. But during COVID, when all the hotels shut down, that enforcement was effectively lost, and there were no longer these consistent eyes on the water. Kahekili is also quite small in area, so this photo captures the full extent of it, also a little bit beyond. So pretty small, which means relatively small amounts of fishing can rapidly diminish the growth in herbivore populations from management. And this is especially true for parrotfish. These fish sleep pinned against the reef or even just out on the sand. So at night, they're just these sitting targets for spearfishers. So spearfishers can just swim around a reef area and very quickly remove those large fish in a population in a single night. And then lastly, because key herbivores like parrotfish are slow growing and long lived, it can take years to build back up those large fish in a population. So proactive management of herbivores in advance of anticipated coral loss may be a more appropriate management strategy, so that by the time the next destructive event hits, hopefully the herbivores are already established in greater abundances across diverse feeding modes and size structures. Considering these lessons learned, Hawaii has scaled up this approach and recently completed a statewide sustainable herbivore management plan as part of the larger Holomua Marine Initiative, which is pretty exciting. Now, when we look across multiple marine protected areas and the effects that they have on herbivores, it's clear we should not expect for herbivore management to be effective everywhere. For the purpose of enhancing reef resilience, this strategy is most likely to be successful in reef areas where there is an algae problem or an algae problem is likely to develop. The herbivore stocks are depleted or the functional diversity of herbivores is depleted. And it's reasonable to expect that management actions can restore those populations, which also means there needs to be sufficient compliance. And then lastly, it's important that any benefits to corals from increased herbivory isn't just completely overwhelmed by these other local stressors, which means you may need to combine herbivore management with other local solutions. All right, so if you want to assess and monitor herbivory as a component of reef management plans, the current practice tends to use estimates of total fish biomass, with this assumption that more herbivore biomass means more herbivory. But importantly, not all herbivores are the same, and they can be categorized into functional groups according to the way they feed and what they eat. Browsers target the upright algae on reefs, whereas grazers target that lower-lying turf algae. And then we further divide grazers according to how they feed and how much of that underlying reef substrate they remove with each bite. Some species shift in their functional role as they grow, like some species of parrotfish that shift from being scrapers to excavators as they're able to take increasingly larger and deeper bites. And feeding behavior can vary with fish size in ways that also differ among species. For example, as parrotfish grow, the number of bites they take while feeding can decrease, increase, decrease in a nonlinear manner, or not change according to any sort of clear pattern. So to provide better estimates of herbivory, recent studies in the Atlantic and Indo-Pacific have started to use an approach that integrates herbivore abundance from fish surveys, with our understanding of herbivore feeding behavior and resource intake that stems from fish foraging observations. My co-authors and I recently developed a similar type of analytical framework for Pacific herbivores, expanding beyond parrotfishes to also include acanthurids, which is the other primary group of herbivores in the Pacific. We first conducted a meta-analysis of fish foraging observations to create a database of herbivore feeding equations that we then applied to the National Coral Reef Monitoring Program to convert fish surveys into estimates of herbivory across the US Pacific Islands. If you are interested in this approach, or if you would like to convert your own fish survey data into estimates of herbivory, everything you need to do so, including the whole database of equations, is publicly available with our paper, which is open access in Ecosphere. Now, importantly, when we assessed how herbivore biomass corresponds with rates of herbivory, we found nonlinear positive relationships where some islands with the greatest biomass did not also have the greatest herbivory. And a clear example of this was at Jarvis Island, where despite having the greatest parrotfish biomass in the Pacific, herbivory was lower than expected for its region, especially for bioerosion. And for a given level of biomass, herbivory varied among regions. And this is because the combination of herbivores that make up that biomass can look quite different across all these locations. So this really emphasizes why herbivore biomass alone is not the best proxy for herbivory. All right, so quick recap. In the face of climate change, herbivore management is a promising tool to enhance the local persistence of coral reefs. This targeted management strategy can be combined with other local solutions to leverage any potential synergies. And our ability to accurately estimate herbivory has recently improved, which enables us to incorporate this ecological process into adaptive management plans. With that, I'd like to thank all the agencies and institutions that have supported, funded, and contributed to all of this work, including all of the crew, coxswains, and divers that have made all of the NCREMP and Kahekili surveys possible.